Hi, we are Yusong-Che, Aram-Seo, and Hyung-Sin Kim from Seoul National University, and I will talk about our work, ScriptPainter, vision-based on-device task script generation for mobile systems. This is our problem definition. When developing mobile applications, we need testing, and there are roughly two kinds of tasks. The first one is large-scale professional testing. It is usually done after development, so the process is done less frequently. And tests are performed for complex scenarios by professional QAs. On the other hand, small-scale testing such as ad hoc testing are performed more frequently during development process and test relatively simple scenarios by developers. Our ScriptPainter targets small-scale ad hoc testing. More specifically, developers need to test their app. For example, after adding a feature to the app, they may submit their code for peer review. And before that, developers need testing so as not to waste time. But testing is a tedious job because most of tests are repetitive process, and even these testing loops are repeated for different devices and for different test cases. In general, they are professional QA engineers and they can easily do repetitive tests. But it's not always an option for ad hoc and small-scale testing environment. We conducted a survey with 24 software developers asking preferred testing tools. Contrary to our expectation, 58% preferred manual testing with screen touch, and 42% use automated testing tools but generate test script manually. Even though generating test script is time-consuming, none of the survey use auto-scripting tools. So we asked the developers reasons for not using automated testing tools. Most of them said manual testing with screen touch is much faster and convenient. And another important reason was that they do not know how to make testing scripts. Because developers are not professional QAs, they don't have time to learn automated testing tools. So we introduced a super easy testing tool for software developers. Our idea is simple and intuitive. How about generating test script by painting, not by typing? Like drawing figures on the paper, we can draw testing scenarios on the screen. Then the test script will be generated automatically. That means we can generate the test script by intuitive screen touch, and developers do not need to learn a complex set of knowledge about the testing tool. Here's the user guide. First, turn on Show Touch option on under Settings. Then a cursor appears when you touch the screen, and disappears when untouched. Next, record a test scenario using the touch screen. You can just click or drag naturally as if you're using the application. The final step is to run the ScriptPainter app and feed the recorded video. Then ScriptPainter will automatically extract the time and location of the cursor from the video. ScriptPainter will take care of the rest and convert it into test script. What's important is that the whole system should be both accurate and efficient. If it's not accurate, the whole test script and the result will be useless. If it's not efficient, it takes too much time. However, because Android's cursor is so small and transparent, it's very hard to find a cursor on the background picture without prior information. So, when extracting cursor information, we use a very accurate DNN-based object detection model for accuracy. But the problem is that running DNN model is too heavy to meet our efficiency goal. So our first solution is to introduce efficient tracker. We selectively execute efficient tracker and run DNN detector only when necessary. To control the execution of two modules, we introduce Frame Manager. When the user feeds the video, Frame Manager receives it first and convert the video into the image frames. Then send an image frame to the detector. By the way, if frame manager sends all frames to the detector, heavy DNA model will process too many frames. It means, again, we cannot meet our efficiency goal. To elevate this problem, we deeply investigate the behavior of the cursor. We find out that once the cursor appears, it reads at least 5 frames. It leads to our second solution, frame sampling. After sending a frame, Frame Manager passes next 4 frames and sends 5th frame to the detector. If the detector finds the cursor at the 5th frame, detector sets detection status as true and sends it to the Frame Manager. Then Frame Manager sends previous 3 frames to the detector so that the detector investigates these frames. This process is rewinding. Rewinding is to reduce false positive error. For example, right after an execution of application, several cursors appears for 2 to 3 frames. In rewinding process, if the cursor drifts too shortly, it is regarded as false positive case. After detection, it's time to run live rate tracker. Detector has time and location of the cursor, and it will generate the bounding box around the cursor and sends all this information to the tracker. Then tracker will investigate just inside the bounding box to track the cursor. That's why even lightweight model can successfully track the cursor. After tracking process, tracker sets track status accordingly and sends it to the frame manager. While track status is true, frame manager executes tracker continuously. But if the tracker misses the cursor, the frame manager will execute the detector again. However, not all tracker models work well. We first tried optical flow because it is widely used as feature tracker. But it frequently confuses the cursor with a background feature. So we use half circle transform because we observed that it correctly finds the cursor without confusion. Also, we devised adaptive bounding box technique. As previously mentioned, live rate tracker can be light because they only investigate limited area. However, if the bounding box is too large, it may lead to confusion. So, to maximize tracker's performance, bounding box should be as small as possible. But here's another problem. If the cursor moves slowly, small bounding box is enough to cover the cursor trajectory. However, if the cursor moves fast, small bounding box will miss the cursor. So we adapt bounding box size according to the cursor speed. Then, bounding box can maintain as small size as possible, covering the expected cursor trajectory. After detecting and tracking process, the next step is to generate test script. Script generator is in charge of this process. While parsing the video, either detector or tracker sends the cursor information to the script generator. Script generator has predefined template, so it incorporates the cursor information into template, then it becomes final test script. To validate ScriptPainter in the real world, we perform a set of experiments with 10 device software engineers. We gave them test scenarios, for example, using embedded memo app following the guidelines. Then they generate test script both manually and by using ScriptPainter. As a result, scripting was done in 86 seconds on average with ScriptPainter. It's 8.3 times faster than manual scripting. Interestingly, ScriptPainter also can reproduce the test scenario more accurately than manual scripting. In summary, ScriptPainter is a super easy, fast, and accurate testing tool. Thank you for watching, and for more details, please refer to our paper.